everyone, Andy from Adaptronic here. In this video I'm going to talk about idle control setup problems and questions that people have. I've done 2 other videos on setting up idle control, so if you've got any questions you should see those first of all. Now, the most basic problem that you could have with setting up idle control is that when you change the idle effort at the ECU, it doesn't actually control the RPM at the engine. Now, there could be lots of reasons for this, but the first thing that I would check is the electrical connections. So the auxiliary outputs on the ECU only pull to ground. So the way to check a 2-wire solenoid valve is to change the auxiliary output on the ECU to none, measure the voltage at the 2 pins on the valve. Now, they both should say 12 volts. If they don't say 12 volts, then you don't have a 12 volt supply connected to the valve. If one says 12 volts and the other says ground, then there's probably a problem with the pins on the connectors, or the valve itself could be open circuit. If they both say 12 volts, then it looks like that's probably connected okay. Now, if you go to the ECU and you click invert, so it says none inverted, then that means that the ECU is always holding the output on. So in this case, the valve should show 12 volts on one side and 0 volts on the other side. And if you've done that, then electrically it's probably okay. When you click invert on and off, you should hear the valve go click, 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 click as you do that. With a 3-wire solenoid valve, you can do the same thing, except you have to check both the outputs from the ECU. If you've got a 6-wire stepper motor and you've connected all outputs to the ECU, then you should check that as well. If you're using a stepper motor driver board, then you need to use the 2 outputs on the ECU. With each output, if it's off, so set to none, then one side of the motor should be 0 volts and the other side, the other terminal of the same coil, should be at 12 volts. When you invert it, those two should swap around. So on a 4-wire motor, if you measure the voltage across each coil, then it should either be 12 volts or minus 12 volts, depending on whether the output is none or none inverted. And if you don't know which pins are the coils on the idle motor, then go back and watch my previous video on idle control motors. Now, if all those are wired up correctly and you're measuring the correct voltages at all the pins, then it's time to check that the idle valve is actually doing the right thing. So if it's a stepper motor, then you can watch the plunger move in and out as you change the step number. With a 2-wire valve, you should be able to hear it go click, 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 click. And with a 3-wire valve, at least you should be able to blow into it and see if air comes out in either situation. If that all operates correctly, then the next thing to make sure is that the air pipes are all connected correctly. You've got air flowing into the input side of the idle motor. The other side that connects to the manifold actually connects through to the manifold, so if you leave that open to air, then it should idle very high, and if you block it with your finger, then the RPM should drop. Now, one question that's really common is it stalls when I stop at a set of traffic lights. Now, like a lot of things with ECUs, it helps a lot if you can take a log of it and then analyze the log. So what normally happens if someone describes that symptom is that the idle effort is actually lower when they're stopping at a set of traffic lights compared to where the engine would normally need the idle effort to be to idle. And normally the reason why that's happening is that the ECU is going into closed loop idle mode when it should not be. So for example, if you've set the ECU to go into closed loop idle mode when the vehicle's stationary and you don't have a vehicle speed sensor connected, or you have a vehicle speed sensor connected but it's not working, those sort of conditions will cause the ECU to go into closed loop idle mode when you're slowing down for the set of traffic lights, when your foot's off the throttle, and the ECU will be dropping the idle effort, and again you'll see that in the log. And then when you finally put your foot on the clutch when you're stopping the car, then the idle effort will be too low and the engine will stall. So the way to fix this, of course, is go back and watch my previous video on setting up idle control. You need to have either a clutch and a neutral switch or a functioning speed sensor. Now, the other most common question that people have is they say it's hunting. How do I fix this? Now, a lot of times people actually misuse the word hunting and they're actually describing a different problem altogether. So I'll go through what people often mean when they say it's hunting so that we can actually get to the real problem. So a really common situation is that the engine actually just has way too much air and it's idling too high. But because it gets above the RPM threshold for throttle off overrun fuel cut, the ECU goes into fuel cut mode, and so the engine stops producing torque. And it stops producing torque until it gets back down to the lower RPM when the fuel cut stops. Now, you can tell that it's going into fuel cut by either looking at the gauges window where it says it's going into fuel cut, or you can look in the F11 window as well where it says it's going into fuel cut there. Now, if this is happening, then it means that your idle speed is just too high. You've got too much air going into the engine, and you should be able to verify this by, if you can block off the inlet somehow, reduce the throttle stop so there's less air getting past the throttle, or some other mechanism like that to reduce the amount of air going into the engine, you'll be able to fix the problem that way. That's number one. So if it's not going into fuel cut, then the engine's oscillating through some other mechanism. And there are three things that I can think of that would cause that to happen. One of them is an actual idle hunt, and you can tell that's happening because the idle effort is moving up and down all the time, and that's causing the RPM to move up and down. The other one is ignition timing. So the ignition timing is advancing and retarding, and that's causing the RPM to go up and down. Or the last one, which is actually quite common, is a rich lean fuel hunt. So the engine gets to a higher RPM with more vacuum, that part of the fuel map is too lean, so the engine loses torque until it comes back down to a lower RPM, there's less vacuum, that part of the map is more rich, so the engine then makes more torque and accelerates again. Like with anything, the way you need to work out which one it is to isolate the system. So you can isolate the ignition timing very easily just by clicking the timing lock function and just locking the ignition timing. You can also lock the idle effort by changing the maximum and minimum idle efforts to the same value just to fix it at a certain location. Or you can set the PID gains to 0 and that'll make it go into open loop. So if it still hunts with those two being locked, then you know it has to be a rich lean hunt. And if you add, say, 10% master trim, then that either should go away or should change. And if it does, then you know it's related to the fuel air mixture. Normally what we need to do in this situation is to enrich the lighter load parts of the map, and that normally fixes the problem. Now when I say the lighter load parts of the map as to where it's actually going, you can use the map trace function to see which parts of the map the engine is actually visiting. Now if it's not a rich lean hunt, then I would suggest unlocking the ignition timing and set the timing ignition ramp rate to 0 and see if you still have the problem. If you do, and if the idle effort is moving up and down, then you need to reduce your PID gains, or you need to use the ignition ramp rate to actually stabilize the idle speed. And if it was ignition timing causing the problem, then reduce the ignition ramp rate. Otherwise, for general conditions such as it stalls after starting, or it idles too low, or it doesn't idle up enough with the air conditioner on, then go back and watch my video on idle control setup. Thanks very much, and for any more questions, please go to adaptronicecu.com.